My name is Mike. We're going to start this presentation now. I'm an employee of Nagios Enterprise along with Nick. He's a part of our development and support staff. He's going to be talking about Nagios performance tuning today. So enjoy.
All right. Hey, guys. All having a good time? All right. I guess I don't need an introduction because Mike took care of that. But what I'll be covering today is some performance tuning, and I'll get more into specifics about what I'll actually be tuning. Just the baseline of what I'm going to be going over is I actually did some tests. I didn't do tests for everything that I'll be covering today, which seemed kind of incomplete, but I couldn't do tests for some of this stuff. And basically what I did is I had a baseline virtual machine that I ran the systems on, and I ran them all the same. And then what I'll be covering is the actual tuning that I did. Mike talked about it last time, RAM disks. I'll go into it a little more detail, what you actually get out of it, how to implement it, and when you should, when you shouldn't, stuff like that. Also offloading MySQL with NDO utils, and offloading that to an actual different server, what the benefits are, when you shouldn't do it, when you should do it, just stuff like that. Also memcached, when you should use that, when you shouldn't, what it means. Also passive checks, kind of get into how you can actually get more for performance using passive checks, when you shouldn't use passive checks, when you should, what the performance benefits are, and then we'll do a final Q&A. So pretty much same setup as last time. All right. So the first thing I'll go over is what the actual baseline system was used for these tests, so you might be able to apply it to your actual systems and if it could actually suit all of your systems. I used a VM running CentOS 6. I gave it 2 CPUs with 1 gig of RAM, and the hard disk was a 20 gigabyte disk. The host version was VMware Workstation 7.1.4. I don't think that there's been any major increases or decreases in disk I/O, which is mainly what I tested with the later VMware versions. But if you guys know of anything, be sure to pipe up and let me know. As far as the actual disk it was operating on, SATA 2, which is capable of 3 gigabits per second. I'm not exactly sure what VMware can actually throughput to the PCI Express bus, but that's what it's capable of. As far as the version of Nagios that I was running Nagios Core 3.2.3. It had 1,002 hosts on it and 4,012 services. The check frequency for everything was 5 minutes. And I did use the NDO utils event broker. So this is just the baseline of what it is, so you guys can apply it to whatever you guys are using. So then what I actually did use to check is pretty similar to what Nagios actually uses to check. If you guys go look in the performance info for Nagios, it gives you like how long it was waiting to do stuff. I used IOStat, which is the same tool that Nagios does uses, and the harvesting method that I used is I just ran this iostat-x 6060 right into a file.log. I did it for a clean, and then I did it for the RAM disk and the MySQL offload and the memcache. I didn't do it for passive checks because that was outside the scope of this test. That would have been a massive project. And I ran it. So then after the test was performed, I reset the virtual machine to a clean state and then redid all the changes and ran it again just in case we hit some spike, something strange happened. You guys know how testing goes. Something strange always happens. And then I picked the test with the least extrema. While that may not be the most statistically relevant way of picking which test to use, it did iron out some of the strange tests that didn't jive with what my prediction for what the actual result would be. And then I allowed for 2 hours of normal operation before going through and running the IOStat method again, just to let stuff even out, find an equilibrium point. And then I parsed the log files and plotted them using some custom scripts. They're pretty simple, so there's no creative math going on in any of these. So the metrics that I'm going to be using for the comparisons are WS, which are writes per second scheduled to the hard disk, reads per second, the await time, and the await time is kind of independent of the speed of your disk. The await time is how long in the queue your file actually waited before it got picked up and said, okay, I'm going to write you to the disk now. I'll go into the reasons why I picked that one instead of the actual total time that it took for this piece of information to be taken and written to the disk. But just for now, that's the one I used. And then the average queue size, that's how many items were actually waiting to be written to the disk. That it could be helpful for a couple reasons. We'll see why in a bit. And the average size, the average cluster size that is written to the disk. So if you've got one thing that's only 1 byte long being written to the disk, that's totally different than one thing 1 megabyte long being written to the disk, and takes different I/O times. So those are the metrics that we'll be using for comparison. If these need to be reset later, because this is kind of in code up here, I realize, just say something and I'll rephrase it. So the first thing I'm going to cover is RAM disks and implementation of, reasons to use them, reasons not to use them, and then I'll show you some of the specs that I pulled out of the actual performance data. So Mike kind of went over this in the previous discussion, but what a RAM disk is, I'm sure I don't need to explain the basics of RAM to you guys, but I will, just so that we can get the concept of why a RAM disk would matter. Mike actually mentioned the status.dat file and the objects.cache file, both of which Nagios writes to and reads from a lot. And they're usually just small writes, and there's just a lot of the writes and reads. So the pro of a RAM disk is it's got incredibly fast I/O. Like there is no seek time in RAM. It has a direct bus straight to the RAM. It doesn't have to go through some intermediary like a SCSI controller or a SATA controller or anything like that. It's just a directly from the processor to the RAM. So there's near zero latency time. It can act as a separate volume to alleviate I/O issues on other particular volumes. So if you've got some hard disk like an SDA 0, you can mount something to make it appear as though their one volume is 2 or 2 volumes is 1. Just however you set it up and you want it to be like that, you mount it as a RAM disk in whatever logical way you find necessary. So it's kind of a tertiary a pro, but it still should be mentioned. The cons of a RAM disk is that it doesn't hold state on restart, which Mike went over. So you don't want to put your super secret code that's going to change the world on the RAM disk, but that's not what this presentation is about. It actually uses RAM, so it's not ideal for large files. Typically, the objects.cache and the status.dat files are usually below 20 megs, unless you've got some unusually large installation, which I'm sure some of you have. But for the most part, you don't need to worry about it. It is still something to consider, though, because you should just see what the sizes are, add them up, and that's about the size that you should make your RAM disk. Well, obviously a little bit bigger to account for some growth and some miscalculation. Also, miscalculations will cause more harm than good. If you assign some massive RAM disk, or you didn't assign enough, it will try and write to that RAM disk, and when that RAM disk is full, it will start paging like it would virtual memory, which will actually cause more CPU calculation. Be like, okay, this can't be on this RAM disk. I've got to page it to the page file. So make sure that if you are going to implement this, make sure you're actually doing your math right and that you're not actually shooting yourself in the foot. All right. So things that should go on here are like storing off and access small files, like what previously mentioned, objects.cache, status.dat, service-perf data. Most of the stuff in the Nagios var directory could go in onto a RAM disk, and you would see some benefit from it. I mean, obviously, it's probably not a big deal to have the nagios.log in the RAM disk unless you've got debugging turned to 1 and every option set to it. Then it might actually make sense, but then you're going to get a log file that's massive, and you're going to run out of RAM disk really quick. Also, beware of the scaling issues, which I mentioned earlier. Like if your RAM disk is not allocated big enough, then you shouldn't even have it in the first place, because it can become very large, and as I mentioned earlier, you'd run into paging issues, and it just becomes, it actually slows down your system if it's not allocated.